A SPA GFCI panel cannot be installed without a neutral wire from the main panel. SPA GFCI panels need a neutral wire to operate correctly. The neutral wire offers a return path for the electrical current. Without a neutral wire, the GFCI cannot identify ground faults and won't trip to protect the SPA or its users. If the electrical installer doesn't answer, contacting them again is an option and requesting them to come back and install a neutral wire from the main panel to the SPA connection box. Also, hiring a licensed electrician can help to get a qualified electrician to assess the situation and provide a safe and compliant solution. A third option is to explore alternative GFCI options that may not need a neutral wire, such as a cord-mounted GFCI or a portable GFCI. It's important to take some safety precautions. Do not attempt to install a GFCI panel yourself if you are not qualified. Keep the SPA disconnected from power until a neutral wire is installed or an alternative solution is implemented. Do not use the SPA if unsure about the electrical safety of the connection. Let's delve into some specifics. The GFCI, or ground fault circuit interrupter, is a safety device designed to protect people from electrical shock. It does this by monitoring the current flowing in a circuit. If the current going out differs from the current returning by a small amount, typically 5 mA, the GFCI trips, quickly cutting off power. This difference indicates that some current is leaking to ground, which could be through a person touching a live wire or a faulty appliance. The neutral wire plays a crucial role in the operation of a GFCI. In a standard 120-volt circuit, the hot wire carries the current to the appliance or device, and the neutral wire provides the return path for the current back to the source. The GFCI constantly compares the current in these two wires. If they are not equal, it indicates a ground fault and the GFCI trips. In a 240-volt circuit, which is often used for SPAs, there are two hot wires, and a neutral may or may not be present depending on the specific wiring configuration. The appliance receives 240 volts by having a 120 volts potential between each of the two hot wires and the neutral. If a neutral is not available in a 240 volts application, the voltage between the two hot wires is still 240 volts, however each of the hot wires will have a different potential with respect to ground. The requirement for a neutral wire in a GFCI protected circuit stems from the way the GFCI detects ground faults. It needs to monitor the balance between the current flowing out to the load and the current returning. Without a neutral wire, this balance cannot be accurately assessed and the GFCI may not function correctly. In the specific case of installing a SPA GFCI panel, the lack of a neutral wire presents a significant problem. The GFCI panel is designed to protect the SPA and its users from electrical shock by quickly disconnecting power in the event of a ground fault. If there is no neutral wire connected to the panel, the GFCI will not be able to detect these faults and will not trip, leaving the SPA unprotected. Several options exist to address this situation. Firstly, contacting the original electrical installer and requesting them to install a neutral wire from the main panel to the SPA connection box is an option. This is the most straightforward solution, as it ensures that the SPA GFCI panel is wired correctly and can function as intended. Secondly, hiring a licensed electrician to assess the situation and provide a safe and compliant solution is another option. A qualified electrician can evaluate the existing wiring, determine the best way to install a neutral wire, and ensure that the entire electrical system meets all applicable codes and standards. Finally, consider a different type of SPA GFCI, exploring alternative GFCI options that may not require a neutral wire, such as a cord-mounted GFCI or a portable GFCI. These devices are designed to be plugged into a standard outlet and provide GFCI protection for the SPA without requiring any modifications to the existing wiring. It's important to note that not all GFCI options are suitable for all SPAs, so it's essential to consult with an electrician or SPA professional to determine the best choice for your particular situation. Regardless of the chosen solution, safety should always be the top priority. Never attempt to install a GFCI panel yourself if you are not qualified, and always disconnect power to the SPA before working on any electrical connections. Additionally, do not use the SPA if you are unsure about the electrical safety of the connection. and always have a qualified electrician inspect the wiring before using the spa for the first time. Furthermore, it's crucial to understand the relevant electrical codes and regulations that govern the installation of spas and GFCI protection. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical systems, including spas. Some of the key requirements include the proper grounding of the spa, the use of GFCI protection, and the installation of appropriate wiring and conduit. It's essential to consult the NEC and any applicable local codes to ensure that the spa is installed safely and correctly. Moreover, it's important to be aware of the potential hazards associated with electricity and to take precautions to avoid electrical shock. Always use insulated tools, wear appropriate personal protective equipment, and never work on electrical equipment while standing in water or on a wet surface. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. In summary, installing a spa GFCI panel without a neutral wire is not recommended, as it can compromise the safety and functionality of the GFCI protection. The best course of action is to contact a qualified electrician to install a neutral wire from the main panel to the spa connection box, ensuring that the GFCI panel can operate as intended. Alternatively, consider exploring other GFCI options that do not require a neutral wire, such as a cord-mounted GFCI or a portable GFCI. Above all, prioritize safety and always consult with a qualified professional before working on any electrical connections. To further illustrate the importance of a neutral wire in GFCI operation, let's consider a scenario where a person comes into contact with a live wire inside the spa. If the spa is properly grounded and the GFCI is functioning correctly, the current will flow through the person's body to ground, creating a ground fault. The GFCI will detect this imbalance in current and trip, quickly cutting off power and preventing serious injury or death. However, if the GFCI is not properly wired or there is no neutral wire connected, the GFCI may not detect the ground fault, and the person could be exposed to a dangerous electrical shock. The neutral wire provides a return path for the fault current, allowing the GFCI to accurately measure the imbalance and trip in a timely manner. In addition to providing a return path for fault current, the neutral wire also plays a role in reducing voltage fluctuations and maintaining a stable voltage level in the circuit. In a properly wired circuit, the neutral wire is connected to ground at the service entrance, which helps to stabilize the voltage and prevent it from drifting too high or too low. This is particularly important for sensitive electronic equipment, such as spa control panels and heaters, which can be damaged by voltage fluctuations. Without a neutral wire, the voltage in the circuit can become unstable, leading to equipment malfunctions and potential safety hazards. Furthermore, the neutral wire is essential for proper grounding of the spa. Grounding is the process of connecting the spa's metal parts to earth, which provides a low resistance path for fault current to flow back to the source in the event of an electrical fault. This helps to protect people from electrical shock by ensuring that the spa's metal parts are at a safe voltage level. The neutral wire is connected to the grounding system at the service entrance, providing a direct connection between the spa's metal parts and earth. Without a neutral wire, the grounding system may not function correctly, leaving the spa vulnerable to electrical hazards. In conclusion, the neutral wire is a critical component of a safe and properly functioning spa electrical system. It provides a return path for fault current, helps to stabilize voltage, and is essential for proper grounding. Installing a spa GFCI panel without a neutral wire is not recommended, as it can compromise the safety and reliability of the electrical system. If you are unsure about any aspect of spa wiring, consult with a qualified electrician to ensure that the spa is installed safely and correctly. When selecting a GFCI for a spa application, it's important to choose a device that is specifically designed for use in wet locations. These GFCIs are typically enclosed in a waterproof or water-resistant housing to protect them from moisture and corrosion. They are also designed to trip more quickly than standard GFCIs, providing an extra layer of protection in the event of a ground fault. In addition to wet location GFCIs, there are also portable GFCIs that can be used to protect spas and other electrical equipment. These devices are typically plugged into a standard outlet and provide GFCI protection for any equipment that is plugged into them. Portable GFCIs are a convenient option for protecting spas that are not permanently installed or for providing temporary GFCI protection during maintenance or repairs. When using a portable GFCI, it's important to ensure that it is properly grounded and that it is not exposed to excessive moisture or water. Another important consideration when installing a spa electrical system is the size and type of wiring used. The wiring must be sized appropriately for the load that it will be carrying, and it must be rated for use in wet locations. The NEC provides detailed guidelines for the selection of wiring for spa applications, and it's important to follow these guidelines to ensure that the electrical system is safe and reliable. In addition to the wiring, the conduit that is used to protect the wiring must also be appropriate for use in wet locations. Conduit is typically made of PVC or other non-metallic materials to prevent corrosion and to provide a waterproof enclosure for the wiring. It's important to ensure that all conduit fittings and connections are properly sealed to prevent moisture from entering the conduit. Finally, it's important to have the spa electrical system inspected by a qualified electrician before using the spa for the first time. An inspection can help to identify any potential problems or safety hazards and to ensure that the electrical system meets all applicable codes and standards. The electrician can also provide guidance in the proper operation and maintenance of the spa electrical system. By following these guidelines and working with a qualified electrician, you can ensure that your spa electrical system is safe, reliable, and code compliant. Remember that electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock. In order to properly protect a spa or hot tub from electrical hazards, several components need to be properly installed and functioning together. This includes a grounding system, a bonding system, and ground fault circuit interrupter protection. Firstly, the grounding system ensures that non-current carrying metal parts of the spa are connected to earth. This provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit in the event of a fault. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the spa's grounding terminal with a grounding conductor. Secondly, the bonding system connects all metal parts of the spa, including the pump motor, heater, and metal piping, to create an equipotential plane. This minimizes the voltage difference between these parts, reducing the risk of electric shock if someone comes into contact with two or more metal parts simultaneously. The bonding system typically consists of a solid copper bonding conductor that is connected to each metal part of the spa with bonding lugs or clamps. Thirdly, ground fault circuit interrupter protection is required for all electrical circuits that supply power to the spa. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly interrupt the circuit, preventing electric shock. GFCIs are typically installed in the spa's control panel or in a separate enclosure near the spa. Regular testing of the GFCI is recommended to ensure that it is functioning properly. In addition to these components, it is also important to ensure that the spa is properly wired and that all electrical connections are tight and corrosion-free. Loose or corroded connections can create resistance, which can lead to overheating and electrical hazards. It is also important to protect the electrical wiring from physical damage and moisture. This can be accomplished by using conduit or other protective enclosures. When installing or servicing a spa, it is essential to follow all applicable electrical codes and safety standards. These codes and standards are designed to protect people from electrical hazards and to ensure that the spa is installed and maintained safely. It is also important to hire a qualified electrician to perform any electrical work on the spa. A qualified electrician has the knowledge and experience to ensure that the spa is properly wired and grounded and that all electrical components are installed and functioning correctly. Attempting to perform electrical work on a spa without the proper training and experience can be dangerous and can lead to serious injury or even death. The National Electrical Code, specifically Section 680.42, covers the requirements for spas and hot tubs. This section specifies the grounding, bonding, and GFCI protection requirements for spas and hot tubs, as well as other safety requirements. It is important to consult this section of the NEC when installing or servicing a spa to ensure that all applicable requirements are met. Furthermore, local codes and regulations may also apply to spa installations. It is important to check with the local building department or electrical inspector to determine what codes and regulations apply in your area. In addition to the electrical requirements, there are also other safety considerations to keep in mind when installing and using a spa. These include ensuring that the spa is located on a level surface, that it is properly supported, and that it is protected from the elements. It is also important to keep the spa clean and to maintain proper water chemistry to prevent the growth of bacteria and other harmful organisms. Regular maintenance and inspection of the spa can help to identify and prevent potential problems before they become serious. This includes checking the water level, the filter, the jets, and the electrical components. It is also important to drain and clean the spa periodically to remove any accumulated dirt and debris. By following these safety tips and guidelines, you can help to ensure that your spa is safe and enjoyable for many years to come. The installation and maintenance of a spa's electrical system should not be taken lightly. It is a complex and potentially dangerous task that should only be performed by qualified professionals. By hiring a qualified electrician and following all applicable codes and standards, you can help to protect yourself and your family from electrical hazards and ensure that your spa is safe and enjoyable to use.